Welcome back, everyone. Today we're doing a deep, seat of your pants walkthrough of the United States Air Force's 2026 Advanced Stealth Fighter. This aircraft represents the latest in a long line of incremental breakthroughs. Cleaner low observable shaping, integrated sensor fusion, and engine and avionics advances that push situational awareness and lethality to new levels. I'll cover the exterior, the interior and cockpit, real-world performance impressions, and, because everyone asks, an estimated price and operational cost. I'll flag anything that's speculative so you know what's confirmed versus plausible. Let's start with the exterior. At first glance, the airframe prioritizes stealth. Expect smooth, continuous curves mixed with sharp faceting around control surfaces, a hybrid approach that reduces radar returns across X and lower frequency bands. The silhouette is lower and broader than previous single-seat fighters, hinting at internal weapons bays sized for a mix of long-range air-to-air missiles and small standoff munitions. Leading edges are serrated, panel seams are minimized, and access panels sit behind radar-absorbent overlaps. The overall finish is a matte, radar-absorbent coating that appears darker and more muted than older fighters. In certain light it almost looks liquid. The intakes are S-shaped and blended into the fuselage to shield the engine face. Cooling and thermal management are heavily disguised. Exhaust nozzles use a mixed flow, variable geometry design with thermal masking to reduce infrared signature and make missile lock-on more difficult. Wing planform is a refined delta trapezoid with truncated tips and active flaperons that suggest a focus on both high-speed dash and lower-speed agility. You'll also notice conformal fuel tanks integrated into the fuselage contours, for range without sacrificing stealth. Externally recoverable pylons are minimal. The emphasis is clearly on internal carriage for primary weapons and sensors. When you do see a bay open, the mechanism is impressively smooth and fast, engineered for rapid weapon swaps and reduced aerodynamic disruption. Sensor and data link antennas are low profile and spread across the fuselage and vertical tails, indicating a distributed aperture approach rather than one dominant nose radar. That arrangement boosts redundancy and gives a 360-degree sensing ability while preserving stealth. Now inside, the cockpit feels like stepping into an evolved glass-age fighter. Expect a single-seat layout with a large, curved panoramic touchscreen combined with a heads-up display and an advanced helmet-mounted display (HMD). The HMD projects targeting cues, synthetic vision, and real-time threat overlays directly onto the pilot's visor, reducing head-down time. Haptic feedback is integrated into the stick and rudder pedals, giving subtle tactile cues for warnings and optimal control inputs. Ergonomics are modern. The seat is molded carbon fiber with multi-point harnesses designed for long-duration comfort, and the center stick is slightly offset for a natural wrist alignment. The cockpit canopy is treated with special coatings for stealth and glare reduction. Canopy fracturing lines are invisible to the eye. Behind the pilot is a compact avionics bay that uses modular compute stacks, essentially swappable processing pods, allowing field upgrades without extensive downtime. That's a big deal for keeping the jet relevant across fast-evolving software and sensor ecosystems. The human-machine interface centers around sensor fusion, radar, electro-optical infrared EO/IR arrays, passive RF sensors, and off-board data links feed a single tactical picture. The pilot sees prioritized threats and recommended maneuvers rather than raw sensor feeds. Weapon employment is semi-automated. Once lock criteria are met, the system suggests solutions and can execute them under pilot authorization. Autonomous assist modes can manage fuel, flight envelope protection, and even missile defeat maneuvers if the pilot chooses a cooperative autonomy profile. Performance is where the rubber meets the runway. Based on comparable technological evolution, the jet likely uses a next-generation adaptive cycle engine or heavily upgraded variable bypass turbofan delivering a high thrust-to-weight ratio and improved fuel efficiency for supercruise, sustained supersonic flight without afterburner. Expect a top speed comfortably in the high Mach range for tactical fighters, supercruise capability for sustained transonic supersonic transit, and exceptional climb rates. Combined with thrust vectoring control and sophisticated flight controls, the aircraft will be highly maneuverable in both dogfight and beyond visual range engagements. Range and endurance benefit from conformal tanks and improved propulsion efficiency. Typical combat radius should outstrip legacy fighters by a noticeable margin, and the internal fuel capacity supports longer loiter times while maintaining stealth. Survivability also gets a boost from electronic warfare suites that blend hard kill and soft kill options, active jammers, adaptive decoys, and directional infrared countermeasures. Combined with low observability and advanced tactics, the jet is designed to operate deep in contested airspace. Sensors and networking are probably the crown jewel. Expect an active electronically scanned array (AESA) radar with low probability of intercept modes, a distributed aperture system for spherical awareness, and a powerful EO/IR turret for long-range passive detection. But the real power is the data linking. Secure, high-bandwidth links let the jet share its sensor picture with other assets, other fighters, ISR platforms, and ground or naval units, in near real time. That turns a single aircraft into a sensor node for a much wider force, which is a paradigm shift from seeking stealthy kills alone to enabling network dominance. What about armament? Internal bays will hold a mix of advanced air-to-air missiles optimized for beyond visual range engagements plus short-range missiles for red flag maneuvering. There will also be capacity for precision-guided standoff weapons and small, smart glide bombs for suppressed air defenses. Open interfaces for third-party weapons are likely, enabling rapid integration of new payloads. Now the elephant in the hangar: price. Public estimates for cutting-edge stealth fighters historically range widely. For an aircraft with next-gen engines, sensors, and modular avionics, a per-platform flyaway cost could plausibly be in the hundreds of millions of dollars range, think comparable or higher than late-model stealth fighters when accounting for inflation and advanced systems. Life cycle costs, including maintenance, software upgrades, training, and sustainment, typically multiply that initial figure over the aircraft's service life. So while a price tag might shock civilians, the military evaluates it in terms of capability per unit and deterrence value. Operational considerations matter. The jet's advanced software-centric design reduces hardware upgrade cycles but increases reliance on secure, resilient software supply chains. Maintenance will require new tooling and trained personnel. However, health monitoring systems embedded across systems should predict failures and reduce in scheduled downtime. Training pipelines will likely use an integrated mix of live flying and high-fidelity simulators linked into the same federated battlespace to speed pilot readiness. In short, this 2026 stealth fighter represents an evolutionary leap more than a leap into pure science fiction. It isn't invincible, but its combination of low observability, sensor fusion, adaptive propulsion, and network capabilities make it a formidable node in modern air power. For viewers, if you love aviation tech, this jet is the near future embodied. A machine where software and sensors matter as much as metal and jet fuel. If you want, I can tighten this into a voiceover ready take for a specific channel length, or convert it to a bilingual script with Hindi lines for local flavor. What do you want next?